Welcome, everyone, to today's podcast on breakthrough innovations in agent distillation. This is going to be one lively ride through the world of AI and business transformation.
Thanks for kicking off. And let me start by saying that Agent Distill is fundamentally reshaping how we transfer complex reasoning and tool usage from large models to much smaller ones, and it's all done without any training cost. Imagine copying a master chef's secret recipe without the need for hours of practice.
Absolutely. And from a technical standpoint, the beauty lies in using model context protocols, or MCPs, which are chunks of distilled reasoning that teachers generate autonomously, forming these self-contained, reusable modules that student agents can directly integrate. It's like having plug-and-play components for AI reasoning.
And on the business side, think of a retail chain that reduced its IT operational costs by nearly 15% by leveraging modular AI components for customer service. Agent Distill could be just as transformative for enterprises looking to scale intelligent systems while keeping costs under control.
I'd like to dive into the technical details a bit. Traditional distillation requires imitating long teacher trajectories with extensive chain-of-thought prompts and gradient updates. But here, the teacher agent generates structured MCPs that are abstracted, clustered, and consolidated so that the student agent can inherit capabilities without additional fine-tuning. It's almost like creating a universal language of problem-solving.
Precisely, and in a way it simplifies the operational complexity. Imagine if every time you solved a problem, you didn't have to rebuild the logic from scratch, but could simply plug in a tested module. That's what these MCP boxes offer, making them not only efficient, but highly adaptable across domains like medicine, finance, and even autonomous robotics.
Ooh, that's a fascinating analogy, like a well-organized toolbox where each tool has a specific purpose and can be deployed without further tweaking. How do you see this shifting current practices in AI deployment?
Well, traditionally, fine-tuning smaller models has been both computationally expensive and time-consuming. Here, the training-free nature of Agent Distill means that organizations can quickly deploy robust AI solutions even if they're using lighter models, creating immediate ROI.
And let's not forget, this technique leverages abstracted protocol distillation so that the student agents can seamlessly integrate functionalities like tool calling for tasks, such as analyzing biomedical imagery, without the overhead of real-time lookup computations, which, as we all know, significantly reduces latency in production systems.
Building on that, one real-world example that comes to mind is how a healthcare provider could use this framework to run diagnostic support tools on lightweight systems in rural clinics, thereby democratizing access to advanced AI diagnostic tools with minimal infrastructural investment.
Exactly. The underlying technical brilliance is the abstraction step during MCP creation. The teacher agent generates raw MCP snippets, then a high-capacity LLM like Claude Sonnet 4 abstracts and clusters them into generalized modules in a sort of code distillation process.
And to add a twist, I think one unexpected insight is that the consolidation process not only unifies parameters across similar protocols, but in a way enforces a uniformity that actually makes the student agent's reasoning more consistent. Everyone's focused on dynamic planning, but sometimes we overlook how consistency in tool usage can be a game changer.
That's a neat point. Consistency is key in both business operations and computing. Can you elaborate on how this MCP box integration works on the inference side from a technical perspective?
Sure, once the MCP box is constructed, it's mounted directly into the student agent's tool interface at inference time. This means that when the student agent encounters a problem, it automatically selects from a repository of verified protocols to resolve tasks without engaging in extra gradient updates or trajectory replay.
It's like having an expert consultant on speed dial, where the agent just needs to decide which tool to pick from this box, rather than re-deriving the entire methodology from scratch. A profound shift in deployment efficiency.
And from a business strategist's viewpoint, this method reduces downtime and maintenance costs. Consider an enterprise where every minute saved per transaction scales up to millions in efficiency gains across global operations.
Not to mention, this approach significantly narrows the performance gap between small language models and their larger teacher counterparts, as tests on biomedical and mathematical reasoning benchmarks clearly show that these student agents, once equipped with the MCP box, match or even outperform some systems reliant on fine-tuned large models.
That's right. The experimental results indicated consistent improvements across multiple datasets like PathVQA and Slake, with gains as high as 48% in some arithmetic tasks, showing the modular approach isn't just elegant but immensely practical.
Wow, those numbers are impressive. So, what are some challenges that might arise with integrating Agent Distill into existing systems?
One challenge is ensuring that the distilled MCPs remain generalizable. If the teacher agent's generated protocols are too domain-specific, the student agent's performance could suffer when facing novel situations. This is where abstraction and clustering are paramount.
Another technical challenge is maintaining syntactical correctness and execution reliability of the MCP code snippets. You need a robust validation process during the consolidation phase, which the framework handles via parameterized prompt-based transformations.
From a business perspective, there's also the need for seamless integration into legacy systems. Companies might have entrenched workflows, so making Agent Distill adaptable to those environments is key to its successful adoption.
I'd add that the scalability of the MCP box is another concern. It works well on benchmarks and controlled environments, but deploying it at enterprise scale requires extensive monitoring and possible improvements in dynamic tool selection over time.
On that note, a contrarian view might be that while modularity is excellent, there's a risk of overfitting the student agent's performance to the pre-constructed toolbox, potentially limiting its creative problem-solving in highly unpredictable situations. So the balance between structure and flexibility is crucial.
That's intriguing, balancing predefined structures with the need for creative adaptation. How do you see future developments addressing these issues?
Future work could involve adaptive MCP construction, where the student agent not only leverages the pre-constructed box, but also contributes to updating the protocols dynamically, supporting continuous learning without expensive retraining sessions.
And technically, introducing meta-learning components to allow the student model to decide when to deviate from a standard protocol and try a novel approach might be the next evolutionary step in agent distillation techniques.
In business applications, envision industries like finance or supply chain logistics, where real-time decision-making is critical. Progressive integration of such adaptive systems can streamline operations while constantly being updated with the latest domain insights.
Additionally, there's potential for cross-domain generalization. Imagine an MCP box that can not only handle medical image analysis, but can pivot to solve problems in, say, autonomous driving systems by merely switching contextual parameters. That would be revolutionary.
I think what's particularly exciting is the possibility of combining these distillation methods with other techniques, like in-context learning distillation, further enhancing both the flexibility and performance of lightweight AI agents while keeping operational costs low.
Incredible insights. This discussion reminds me of the 80-20 rule. A few well-constructed modules can solve most problems if you get them right. What advice would you give to organizations considering adopting this technology?
I'd say start small. Identify the critical tasks within your workflow that could benefit from modular automation, and pilot an Agent Distill framework on those problems. Observe the performance improvements before scaling up.
And technically, invest in building a rigorous abstraction and validation pipeline for your MCP construction. It's not magic, but it's engineering excellence that makes the system robust and reliable.
From a strategic standpoint, integrate these systems with clear metrics for performance and cost savings. Real-world examples, like how some tech firms reduced energy consumption in data centers by borrowing modular reasoning, provide a powerful incentive.
I'd also caution not to underestimate the importance of security. Transferring protocols between agents must ensure that no vulnerabilities are introduced, so secure protocol generation and validation must be baked into the design.
And one final unexpected insight. While many focus on speed and accuracy, often the real competitive advantage comes from the flexibility to pivot. This framework allows you to quickly adapt to unforeseen challenges, a trait that's invaluable in today's rapidly changing tech landscape.
That's a striking point. Adaptability is the cornerstone of modern business. As we wrap up, what are your closing thoughts on the future of training-free agent distillation?
I'm optimistic. Agent Distill shows that you can break the mold of traditional AI training pipelines by leveraging teacher-generated modules, which is both cost-effective and scalable.
Technically, it opens a new frontier where we see efficient knowledge transfer without the heavy computational load, setting the stage for smarter, leaner AI systems.
Strategically, businesses that adopt these methods early could gain a significant competitive edge, optimizing operations while maintaining agility in innovation.
And from an engineering perspective, this marks a shift towards modular, composable AI design, where the focus is on reliable plug-and-play functionalities instead of monolithic systems.
Ultimately, it's about rethinking how we achieve intelligence in machines. By breaking down complex tasks into manageable, reusable components, we're likely to see a wave of innovation that democratizes high-performance AI across industries.
What a comprehensive discussion. Thank you all for your rich insights and lively debate. This conversation truly illustrates how blending technical innovation with strategic business applications can forge a new path in AI.
Thanks for having us. It's been a pleasure to share and explore these ideas together.
Absolutely. It's exciting to see where this will take us next.
I look forward to seeing the impact in the business world, especially as these technologies begin to mature.
And I'm eager to dive deeper into the technical challenges and breakthroughs that lie ahead.
Here's to a future where smart modular design propels us into the next era of AI innovation. Thank you everyone for the engaging session.
That's a wrap on today's episode. Stay tuned for more discussions on cutting-edge technology that's driving the future of business and AI. Welcome back to part 2 of our deep dive. Now we're going to get into the nitty-gritty technical implementation of Agent Distill, breaking down the MCP generation, abstraction, clustering, and consolidation steps and how they translate to tangible business applications.
Let's start with the backbone. The teacher agent runs on high-capacity large language models, and its MCP creation module is our star. It generates raw snippets of tool use strategies during task execution, much like a seasoned developer writing modular code on the fly.
Exactly, and the process begins with the teacher's trajectory generation. As it interacts with different subtasks, it produces chains of reasoning and tool calls, which are then isolated into these self-contained MCP segments for further processing. Think of it as distilling a complex recipe into its fundamental ingredients.
From the business standpoint, this means that instead of re-engineering complex workflows every time, enterprises can build a library of these distilled modules, the MCP box, that significantly cuts down time to market. Much like reusable code libraries in software development, streamline product iterations.
Technically, the abstraction phase is fascinating. We pass raw MCP snippets through a high-capacity LLM, such as Claude Sonnet 4, which transforms them into parameterized templates. This involves rewriting the raw Python code to remove example-specific details while preserving the core logic, making them broadly applicable.
And don't forget clustering. After abstraction, similar protocols are grouped together using code-level clustering algorithms enabled by prompt-based instructions, which categorize these reusable modules into functional groups like image processing or symbolic arithmetic. It's a bit like organizing a tool chest by tool type.
That's a great analogy. A well-organized toolbox is invaluable on a busy worksite. Can you explain how consolidation further solidifies these groups into a production-ready MCP?
Consolidation is the stage where each cluster is merged into a single unified protocol. Here, the LLM processes multiple similar MCPs to produce a general-purpose MCP with configurable parameters. Imagine merging multiple versions of a function into one robust API.
Once consolidated, the MCP box becomes a drop-in module for student agents. These agents, operating on smaller language models, integrate the entire MCP box during inference. They invoke these protocols directly as callable tools, bypassing the need for on-the-fly code generation, which drastically reduces inference overhead.
For a business leader, this translates into lower operational costs and faster deployment cycles. Companies no longer need to fine-tune every single model or retrain systems for every new task. Once your MCP box is built, it's like having an agile operations manual ready to roll out across departments.
Let's touch on the inference architecture. Student agents remain completely frozen in terms of learning, which means no gradient updates, and they rely on pre-constructed MCPs for their decision-making. This is critical because it avoids the complexities and computational costs of continual training.
And there's a brilliant synergy here. While the teacher does all the heavy lifting by generating and validating the MCP code, the student simply acts as a smart orchestrator by deciding which MCP to invoke based on the task context, making the entire system highly efficient.
It's like outsourcing the heavy coding work and keeping the logic lean and decision-focused. This technical separation has huge business implications in scalability and rapid prototyping.
Absolutely. And when you look at practical applications like biomedical image analysis, say detecting abnormalities in brain MRI scans, the MCP box encapsulates the necessary analysis protocols, allowing even a lightweight model to coordinate nuanced parameter adjustments like region-specific analysis and threshold tuning.
In fact, the paper's example where two nuanced protocols were consolidated into one parameterized function demonstrates how abstracting from multiple specialized implementations can yield a versatile tool that adapts to diverse diagnostic scenarios without retraining.
I'd add that this approach is transformative for industries like finance too. Imagine a financial service where real-time analytics require rapid, on-the-fly decision-making. The modular protocols can be adapted to different types of market data, enabling predictive analytics without the constant need for retraining models.
From a technical nuance perspective, it also involves careful validation. Each MCP undergoes a syntactical and execution check in a virtual environment before being integrated into the MCP box, ensuring reliability and robustness, which is essential for mission-critical deployments.
And let me throw in an unexpected insight. While many efforts focus solely on improving the LLM capabilities themselves, this method shows that sometimes structuring and reusing existing capabilities in new ways can yield groundbreaking improvements without the need for heavy computational resources.
That's a fantastic point. It's all about leveraging what you have intelligently. As we wrap up this deep dive, what would be your final words for tech and business leaders considering implementation of Agent Distill?
Start by building a pilot project focused on a critical workflow. Approach it like you're assembling a set of Lego blocks. Each MCP is a block that, when put together correctly, builds a powerful, flexible system.
Ensure your abstraction and clustering pipelines are robust. Invest in a good validation process for each protocol, as that's what guarantees operational reliability, much like rigorous quality control in manufacturing.
Strategically, think of this as an enabler for rapid innovation. The ability to plug in and reuse modular AI functionality can give your enterprise a substantial edge in agility and responsiveness.
And technically, focus on integration, not only within the AI components, but across your legacy systems. The less friction you have between high-performance AI modules and operational systems, the faster you'll see tangible benefits.
Ultimately, this training-free distillation paradigm isn't just a technical trick. It's a modular, scalable approach that redefines how we think about transferring complex reasoning capabilities, making advanced AI accessible and cost-effective for a wide range of industries.
Incredible insights all around. Thanks to our experts for breaking down the technical deep dive and showing us how these advanced concepts translate to pragmatic business solutions. Stay tuned as we continue exploring these next-generation AI strategies in future episodes. As we bring this episode to a close, let's take a moment to summarize our end-to-end journey through Agent Distill and the engineered path from teacher agents to streamlined student agents.
In essence, we explored how the teacher agent generates raw MCP snippets during complex reasoning, which are then abstracted, clustered, and consolidated into a robust, reusable MCP box, truly like building a modular toolkit that brings order to chaos.
Right. And on the technical side, the abstraction process using high-capacity LLMs to parameterize code, followed by clustering similar functionalities together and consolidating them into a unified protocol, represents one of the most innovative aspects of this framework, a method that bypasses costly retraining altogether.
From a business perspective, this means that companies can deploy intelligent agents that are not only cost-efficient, but also flexible enough to adapt to diverse applications, from biomedical imaging for detecting abnormalities to financial analytics that drive real-time decision-making.
And let's not forget the practical side. The inference architecture allows small language models to remain frozen, yet highly effective, by leveraging a pre-built library of functional protocols, which is a game changer in reducing operational overhead and improving deployment speed.
I'd like to add a contrarian view here. While much of the AI industry chases ever larger models, Agent Distill reminds us that clever modularity and smart orchestration of existing capabilities can achieve breakthrough efficiency without overwhelming resource consumption.
To sum up, our discussion highlighted key innovations: the training-free agent distillation paradigm, the meticulous process of MCP generation and refinement, and how these technical feats directly unlock new business opportunities through rapid integration and cost savings.
Exactly. Think of it like creating an agile operations manual where every protocol is a pre-tested Lego block, ready to be assembled into industry-specific solutions with minimal fuss.
And the beauty is that this approach not only scales, but also democratizes advanced AI reasoning, making cutting-edge capabilities accessible without the exponential compute costs typically associated with large language models.
Businesses across sectors, from healthcare to finance, stand to benefit as they can achieve rapid innovation, improved reliability, and a more adaptive response to emerging challenges by incorporating such distilled tools directly into their operations.
Ultimately, Agent Distill underscores a timeless business heuristic, the 80-20 rule. Focusing on high-impact, reusable elements from complex processes can yield significant returns without reinventing the wheel each time.
In closing, leveraging structured protocol distillation not only paves the way for efficient AI deployment, but also challenges the notion that bigger models are always better, pushing us to think smarter and more strategically about our technical and business assets.
Thanks to everyone for sharing these in-depth insights and vivid analogies. Today's discussion really illuminated how Agent Distill transforms advanced technical breakthroughs into practical, scalable business solutions. Stay tuned for more episodes as we continue to bridge the gap between complex AI innovations and real-world impact.